Who the hell wrote this code? Hello guys, it's Johnny Time here and welcome to another smart contract security tutorial. There is a lot of buzz going on around the PayPal's new stablecoin PYUSD and the smart contract, that it's written in old Solidity version, that it's super centralized, and everyone is talking about it in the blockchain and crypto community, especially on Twitter. So my name is Johnny and I am a Web3 security researcher, and in today's video we're gonna go through the PayPal new stablecoin smart contract that is written in Solidity, and we're gonna examine the code and see how safe it is to use the new PayPal stablecoin, how the code is written, is it good code or bad code, and how centralized the code is. So I'm super excited, so without further ado, let's get started. So this week PayPal announced, as you can see in their official X or previously Twitter account, today we are unveiling a new stablecoin, PayPal PYUSD. It's designed for payments and is backed by highly liquid and secured assets. Starting today and rolling out in the next few days, you will be able to buy, sell, hold and transfer PYUSD tokens. Learn more, and then they have the page PYUSD in PayPal.com. These are the smart contracts that are already deployed on the Ethereum blockchain, as you can see over here. We'll get to that in a bit later, and we're gonna analyze exactly how the smart contract of the PayPal so-talked USD coin, stablecoin, how they look like and how they work. But before, I want to show you some popular tweets that were posted in the Twitter crypto community. First one by Harrison: time for a pop quiz. Is this A, North Korea's new token, B, PayPal's new token? Making a joke about the fact that the token is very centralized, and attaching here a picture about two Solidity functions, freeze and unfreeze. Then we have another one by Saigar. So the PayPal stablecoin contract is written in an extremely old version of Solidity, allows the owner to pause all transfers, allows the owner to freeze addresses to prevent actions, allows admin to increase the total supply at will, centralized but transparent, at least, right? Because the other things in the financial system that we're used to are also centralized, but here it's at least transparent. We will get to this code later to see exactly how they do it. We have another one by Fubar. PayPal's PYUSD stablecoin is written in Solidity 0.424. Come on, right? A lot of people made jokes about it, that they use Solidity version from 2018, such an old compiler version, while we have Solidity version 0.8.20. It's previous versions of Solidity. We have another one by Pashov. This one gone very viral, 1.1 million impressions, and basically he shows, we will get to this code section later, but he shows that they not only can freeze your assets, but they can also wipe your assets. So if your account is frozen, they can just remove your tokens from the balances, from circulation. So if you have $1 million, you can wake up next day and have nothing just because the admin decided that you should have nothing. This is very centralized. And a lot of other posts by Bytes, by Vitali, what he noticed about the decimals, about the multisig, about upgradable proxy. So now that we see that everyone is talking and basically laughing about this coin, about this contract, we want to take a close look at the contract together. I am a smart contract security developer and security researcher, and let's take a look at the contracts and see really how it looks like and how centralized it is. So if you go to Etherscan, you can see the contract is already deployed, but if you go to the original token address, you will see that actually this is a contract called admin upgradable proxy. What does it mean? It means that it's not the real token contract, but just a proxy that will connect between user transactions to the contract itself, to the token contract itself. Basically, it means that every time someone sends transaction to the smart contract, it goes through this proxy, and then this proxy forward the request to the token smart contract. Now, you might ask why this is the case, and the answer is upgradability, okay? Smart contracts in Ethereum blockchain, in EVM blockchains, cannot be upgraded. It's not like a software that you have a server running and you can upgrade and push new version, new code, patch. In smart contracts, it's not possible. You can, once you deploy the smart contract, you cannot upgrade the code, you cannot patch it, you cannot change the code. So if there is a bug, if there is security vulnerability, or if you want to add features, you cannot do it like in traditional Web 2 apps. That's why we have upgradable contracts, and that's why it's called admin upgradable proxy. Using upgradable proxies, you can actually write a smart contract and upgrade its logic. So if you want to change the functionality completely, you can do it, which is kind of making the smart contract from immutable to mutable, because you can update the code at any time. An admin can do that. Admin with special permissions, with special access, can change the functionality. So it's a smart contract on Ethereum, which is supposed to be decentralized. That's the whole idea behind smart contracts, that you cannot change them, that once the code is on the blockchain, everyone can see it and validate the code that it doesn't do something bad. But in that case, because we use upgradability, it adds centralization to the equation, which means that the PayPal managers, the PayPal company, can all the time change the code and update the code of the token, which adds a lot of centralization to this whole idea. So why would we even deploy a token why would you use blockchain if you can just change the code and basically you lose the immutability and the decentralization? That's what many projects choose to do, and PayPal also chose this path to make the contract upgradable. But behind this admin upgradable proxy, we have the original implementation, which really implements all the functionality of the PayPal USD token. This is the PYUSD implementation, as you can see over here. And this is the code here in Etherscan. Now, the code is not very nice looking and without syntax highlighting. So I copied the code and used VS Code over here with some kind of extensions to have syntax highlighting and special features as well, so we can analyze the code externally. So this is the exact same code from the blockchain, from the Ethereum blockchain. This is the code that represents the PayPal PYUSD token, and now we're gonna analyze it and see exactly how it works. So just from first observation on the contract, we can see that they use Solidity version 0.4024, which is very old version of Solidity, like it was mentioned in the tweets by all those people on Twitter. So they use very old compiler from 2018, even though the contract is written in 2013, 5 years old compiler. Why they didn't use a newer version? This is raises a lot of question marks. And they also use a library that's called SafeMath, because in Solidity versions prior to 0.8, we have overflows and underflows with integers. So it can lead to a lot of unexpected behavior and security vulnerabilities. And that's why we have to use in this kind of versions a library called SafeMath, which is as it sounds, it's safe math. It makes sure that our mathematical operations, our arithmetic operations like sub, like add, all those operations are safe. So there is no overflow and underflows. And this stablecoin is using this safe math library. Now, this is the actual PYUSD implementation, the actual contract. And as you can see, it doesn't import any other contract. Usually tokens, ERC20 tokens or fungible tokens, they use some kind of standard. So they want to follow the ERC20 standard. So they use some kind of implementation that was already made for them by known companies in the industry, such as OpenZeppelin or Soulmate, and instead of like reinventing the wheel. But it seems that PayPal decided to reinvent the wheel and write the whole functionality from scratch instead of inheriting libraries that are well tested, that are battle tested by OpenZeppelin or other companies that are being used in the wild for a while. They decided to reinvent the wheel and implement all the ERC20 standard functions interface by themselves. So this is very interesting decision by the PayPal developer not to use already created libraries, also for ownable, for adding access control to the smart contract to certain functions. Usually people inherit ownable library by OpenZeppelin or by Soulmate, but here we don't inherit any smart contracts, we don't import any smart contracts, but all the logic apart from the SafeMath library is being implemented on the contract itself. So we can see that we are using SafeMath for any data type of UN256, and here we can see we start to have the state variable. This is all the data data that the smart contract holds on the blockchain. You can look at it like a database. So this is all the data about the contract. This is a Boolean that says if the contract is initialized, because it's behind proxy, then there is some kind of state variable that says if the contract is already initialized or not. We have the basic data from ERC20 standard, which they wrote it themselves instead of using the actual implementation by OpenZeppelin. So we have the balances mapping that says maps between an address, an account, to the amount, how much it counts, how much balance every account has. We have the total supply, the name of the token, the symbol, and the decimal numbers, which is 6. This is another mapping from ERC20 standard allowed. It allows basically to approve some spender to spend your tokens. So it mainly used when you want to approve smart contract to spend your tokens, when you do a swap in Uniswap, for example, or in a lending protocol, you provide assets. So when you approve another account to spend your tokens, he can call later on the transfer from function in order to transfer the token from your account to his account or another account. So this is something of the standard that they just implemented themselves. And these are all the things that are not in the ERC standard. It's extra features that they added, such as owner. There is an owner for the contract, an address, if the contract is paused or not, which means it tells us that they can pause the contract. So it's very, very centralized. They can just decide that no one can transfer tokens and that's it. No one will be able to send tokens to any accounts. Asset protection rules, frozen. This is something bad, frozen mapping. So they can probably freeze assets. Supply controller. So there is an account that controls the supply that probably can mint and burn tokens, very inflationary, deflationary token. Someone is controlling its supply like dollars, like Federal Reserve. And proposed owner, this is for two-step process of transferring ownership from one account to another, and some kind of delegated transfer data beta feature that they added to the contract. This is in order to transfer tokens with signature instead of transactions, but this is something that we'll get into later. We have some other constants here as well for domain separator. We won't get into every single one of them, but here are some events that they raise while calling different transactions. And the initialize function. This function will be called one that's after the smart contract is deployed to initialize it with the state variable. So the message sender is the one who is calling this function. So he will be the owner, which will have probably a lot of power over the smart contract. He will be able to call functions that has a lot of rights, a lot of power, that are only owner protected functions. We see that we set the asset protector rule to address 0. There is some kind of another role in the contract that is initially not being set. The total supply is 0 because we just deployed the token. We didn't mint and create any tokens. The supply controller is also the message sender. So there is three roles: owner, asset protection role, and supply controller. And these two are the message sender. So it's the same account, even though it's two different roles, there is one single account that controls them. Then why would you make two separate roles if you have one account that controls them? A very good question, but it seems like the developer of this smart contract doesn't have too much knowledge about Solidity, or it's a bit like all over the place. We will see it in a moment also of the way the contract is organized and the functions are written. This is another function to initialize the domain separator to differentiate the token between different blockchains, because probably this token is going to be deployed on multiple EVM, Ethereum Virtual Machine, based blockchains, and changing the initialize to true. So there we go. We initialize the smart contract. The PayPal admin, the PayPal CEO, whatever, deploys the smart contract, initialize it with all this data, all this information, and he will be the rightful owner of this contract, which allow him to do a lot of things. Now, as you can see, there is a view function, and then here we have a public function that changes the state, then another view function, then another function that changes the state, which shows me that the developer didn't really think through about the order of the functions. Usually, when you write smart contracts, you aggregate all the view functions in certain section, then all the functions that change the state in a different section, all the admin protected, the owner, the centralized functions, so-called, in different section. efficient. But here it seems like it's all over the place. All the functions are mixed with each other. We have view total supply function, then function that is writing and changing the state transfer, then another view balance off, then another function change the state transfer from. Then we have admin functions. It's a bit all over the place and not organized. And the first function that I want to take a look is the transfer function. This is the function that we call anytime we want to transfer tokens from one account to another. So if we possess, imagine that you have PYUSD, you have $1,000 in your wallet and you want to send it to another wallet, then you will trigger this transfer function. You will provide the to and the value. So it makes some sanity checks here, required statement, and here the second required statement, this is what makes this contract super centralized. It basically checks and makes sure that the frozen to is set to false and the frozen from, which is you, the message sender, the one who sent the transaction, is set to false as well, which in simple terms means that you are not frozen, because if you are frozen in this mapping that is called frozen, if the admin decided to freeze your assets or the destination asset that you're trying to send to someone that he is frozen, then this transaction will be reverted and you won't be able to send your tokens. Your funds are frozen, right? It's super centralized. Someone can decide, the owner or the asset controller or whatever they call it, can decide that your address, you are a bad actor, you did something illegal, maybe you voted to the wrong party, maybe you didn't follow the PayPal guidelines, We know how it is with PayPal, right? They take commissions from everything and they can freeze your funds in PayPal, really. So they can do the same here in the smart contract with your token. They can decide that your account is bad and that's it. You cannot use your funds. They are frozen. You cannot transfer them, never. Now, it would be funny, PayPal, they take like 4 to 5% every transaction. They could add here like this fee to the PayPal treasury, but they didn't do it. At least they didn't take these highly crazy fees from the transfer function. But they might add it later in the future, because if you remember, the contract is upgradable. So they can change the transfer function in the future and make sure that every transfer, they take 3% or 4% fee to their account, to the owner account, to the treasury account, whatever. Right now, they didn't do it, but they can still freeze your assets. So bear in mind that when you use the PYUSD token, your funds can be not stolen, but frozen, right? So if you hold those dollars in your wallet and you think that your key is your money, it's not really your money, because the admin can decide to freeze your asset. And this is something that also happens in USDT and USDC, which are so-called centralized stablecoins. Now, the transfer from function is similar to the transfer one. It also follows the ERC20 standard, but this is function that allows you to transfer tokens if someone approved you to spend his token. So you're not transferring your tokens, but you're transferring another account token. You can provide the from address, as you can see over here. And if this from address approved you as the spender to spend those tokens, then you can send those tokens on his behalf. And as you can see, this function as well has the frozen check. So it makes sure that to, the from, and the message sender, so all of the parties, right, all of them should not be frozen. Not the from, not the to, and not you that is using this approval. If one of them is frozen, then it will revert with message address frozen. Now, as you can see, we do all these simple operations. So basically we reduce the value from the from account, which is basically where we take the money from, and we increase the balance in the to account, right? And we remove the allowance, because the from account allowed you, the message sender, to spend his token, but now you use this allowance and you call the transfer from, so now you're allowed to spend less tokens. So this is what happens in this line of code. Pretty simple and straightforward function if you're familiar with the ERC20 standard and the ERC20 token. If not, make sure to subscribe to the channel, because I have so much valuable videos to teach you Solidity and smart contracts. Another interesting thing about the transfer function is when not paused modifier. This modifier basically prevents people from transferring tokens when the contract is paused. What it means? It means that the admin of the contract can come and say, emergency, the contract is paused. No one can transfer tokens, and no one can basically transfer and use their PYUSD tokens. So this is basically a state variable that is controlled by the owner of the contract, and it can prevent anyone from using their money. So these are the approve, increase approval, and decrease approval functions that are basically affecting this transfer from function. So in order to call the transfer from function and transfer tokens from a certain account, this account needs to approve you. You can do that by calling the approve function or the increase approval or decrease approval function. And yes, you can see all these functions are also include this when not paused modifier, and they also include this frozen check. So you basically, if you are frozen or if the contract is paused, you can do nothing with your money. You cannot approve an account, you cannot transfer tokens, you can't do anything. So this is very centralized. And if you thought that you are using blockchain for decentralization while you're using PYUSD tokens, then you're doing something wrong, because this is highly centralized, same as any Web 2 server or database where they control the data and they can control what you can or cannot do with your money. Now here we see these are the ownable functions. Again, we see a modifier here in the middle of the code section in line 300, which is also not a common standard when you write smart contracts. Usually you put the modifiers on top of the Solidity file, but here again, the code is all over the place. It doesn't seem like the developer is very has code standards or very experienced, or maybe they copied it from another code version. And here basically the owner can propose a new owner, so they can simply transfer the ownership to another account. Maybe if this account, I don't know, is not updated anymore, they want to change the ownership, they can do that. Now let's see what the owner can do. The first thing that the owner can do is reclaim PYUSD. What does it mean? Sometimes people mistakenly send tokens of PYUSD directly to this contract, to this ERC20 contract, which is stupid because this contract doesn't have anything to do with those tokens. Usually these tokens, when people send tokens to the token contract, they're gonna be stuck forever. But this function is in order to restore the tokens. So it's gonna do a very simple thing. It's gonna transfer all the tokens from this smart contract that this smart contract owns, which means all the tokens that were sent by users by mistake. To whom? To the owner. Maybe the owner is manually gonna send back to the users, but it's up to him. He can decide if he wants to keep this money on his account or to send it to the users who sent to the contract money by mistake. So it's kind of function to rescue the funds, but it's for the grace of the owner. He can decide if he actually wants to rescue it or keep the money for himself. So another centralized function that is protected by the only owner modifier, which means that only the admin, the owner of this smart contract, can call and trigger this function. So here are the pause functions. So as you can see, the owner can decide whether to pause or unpause the contract. If he pauses the contract, no one can transfer tokens, no one can approve accounts. Basically, the whole functionality for the users are paused and they cannot use the contract. Now, this is the other function that allows the owner to set this asset protection role. So it should be another account that is basically has a role that is called asset protection. So he's protecting your assets, apparently. Let's see how he does that, how he protects your asset in a very centralized way. And here we have another modifier to make sure that the caller of the transaction is the only asset protection rule. Here we go. These are the freeze and unfreeze functions protected by the only asset protection role modifier. So this asset protector is protecting you from using your money, right? So you can call the freeze and unfreeze function. It can provide an address, and if it do that, it's gonna update the frozen mapping. And as we remember, if you're gonna be in this blacklist, in this frozen list mapping, you are not allowed to use the PYUSD token. And this asset protection account can decide if you can or cannot use your tokens. FYI, highly centralized. Now, this freeze and unfreeze, it's something that we see in many centralized tokens because they want to follow regulation. You know, it happens also with USDT and USDC, and they need to do this in order to be approved in the SEC of the United States and to have their license. But this is function that we never seen before in any centralized contract, ERC20 contract, and this is actually crazy. And this is what Pashov tweeted about, and it went super viral. This function is called wipe frozen address. Yes, wipe frozen address. Only again, the asset protection rule can call this function, providing an address, and he can say that basically we require that the address is frozen. So he needs first to call the freeze transaction. He basically called the freeze function to freeze your assets, and then he can call the wipe frozen assets. And what it simply does, it's gonna wipe your assets, guys. Not only freeze your assets, but wipe your assets. So let's say you had $10,000 in your wallet, not in a centralized exchange, not in, I don't know, Binance or Coinbase. You have it in your MetaMask wallet, in your Ledger wallet. You have PYUSD tokens. Not only that this asset protector can freeze your account, it can also wipe it. Basically, change the balance, your balance to zero. So it doesn't matter how much money you have. After he calls this function, you will have zero money, zero PYUSD tokens in your account. And this is something new. This is like new level of centralization that we've never seen before, which gives the grade, Z for PayPal in centralization. This is the most centralized token that I've ever seen. They can not only freeze your tokens, but wipe your tokens. Your tokens can disappear because they simply change the balance mapping, which keep track of how many tokens you possess. And if you have zero, which means you don't have tokens. Now to the last part of this smart contract. If this wasn't centralized enough, let's add some more centralization. This is the cherry of the smart contract, the sweetest part of the smart contract, the supply control, right? So we have a function here to set the supply controller. This is the account that will control the supply of the PYUSD token. This is the modifier. And here we have two functions which the supply controller can call: increase supply and decrease supply, right? They can print and mint PYUSD tokens how much they want. The supply is not capped. We don't have any supply cap. The supply controller can simply call the increase supply cap with value, with this parameter value, and then as you can see, this supply will be added to the supply controller account, which means that it can just call this function with billion new tokens, and this supply controller account is going to have 1 billion new PYUSD tokens. No cap for the supply. That's it. Centralized. One account can just increase and decrease the supply. So is it centralized? I don't know, guys. You tell me. Is the PayPal USD stablecoin centralized after we saw all this increase supply, decrease supply, freeze, wipe frozen assets? Yeah, this is very centralized. Is it safe to use? You decide. Try to think of all the functions, of all the features that the admin and the supply controller and the asset protection can do, and you just have to think how well you're gonna sleep at night with PYUSD tokens in your wallet. I wouldn't sleep well while I know that there is some person that controls some wallet and he can simply not just freeze my assets, he can also pause the whole contract and he can also wipe my assets. So it might be my hard working money and I want to keep this value in PYUSD tokens, and I wake up one morning and I cannot use them, or even worse, they are wiped for my balance. So I wouldn't use this token unless I have to, This is highly centralized with like a new level of centralization. This is the last beta delegate transfer function beta, it's like ERC20 permit, where you can basically approve someone to send your tokens, to use your tokens without sending the approved transaction, but providing him a signature, and he can present the signature to get your tokens. But we won't get into this because this is too technical for this video. I just wanted to show you the overview of the PayPal contract, The real PYUSD PayPal stablecoin contract, this is the contract that the PayPal developers wrote. Solidity version 0.4, very not organized and super centralized. Let me know what you think in the comments below. If you like this video, consider liking it and subscribing to the channel to more awesome smart contract analyze, smart contract security videos. Thank you so much. I was Johnny and I will see you in the next time.